All right, so what you have is the situation. Throughout the day, the depth of the water at the end of a dock varies with the tides. The table shows the depths of water, y, in feet at various times through the morning. We're going to use a cosine function to model the data, where time is t and t equals 0 corresponds to midnight. So what I did for you in the skeleton notes was I gave you some space to do some work. It might be so much work that you had to flip over to the back of the page. And then we also have like a grid. So what I'm going to do is actually do make a scatter plot of the data. I think you may have seen a scatter plot before. But before we do that, let's label our axes. So we know that the horizontal is going to be time, and the vertical is going to be depth and feet. You can label it like over here if you want to. Sometimes just put it way up there at the top. All right. Looking at my data, we have time, and it says that 0 equals midnight. So midnight will be 0, and then these are going to be the number of hours after midnight. So I have to go from midnight out to noon, so from 0 to 12. So we want to kind of count our grid lines here and see if we can, do we need to go by 2s or do we need to go by 1s? How many grid lines do I have horizontally? 15. So I have more than 12, so I can just make every grid line 1 hour. But I'm only plotting at the 2 hours, so we can say that's going to be 2 a.m., 4 a.m., etc. Okay, for my vertical axis, I want to look at how the highest value, what's the highest value for my y? 11.3. So how many grid lines do I have going up? So I can maybe just make one grid line represent 1 foot. So we'll do the same thing going vertically. So we can have 2 feet, 4 feet, etc. So when you're doing this, it's important to set up your axes correctly so you get a nice graph. All right, now we're just going to plot the points. So at midnight, 3.4. So if you plot all those points, you can see we can go ahead and draw like a curve where it looks like if we were to connect them, it would have a nice smooth sinusoidal kind of curve. And I went ahead and highlighted, just because I remembered I did this earlier today, that the highest point is 4, 11.3, and the lowest point is 10, 0.1, because we're going to be using those. All right, so everybody's comfortable with the scatter plot? All right. We're going to want to use a cosine function to model the data. So remember, your cosine function standard form will be a cosine of bx minus c plus d. So we need to find the values of a, b, c, and d that will fit that data. I find it easiest to start with the vertical pieces. So let's start with the vertical translation, and then we can move into the amplitude. So what do you think about finding the vertical translation? Yeah, so how are we going to figure out where the midpoint is? How are you going to find the middle between 11.3 and 0.1? So it's an average then, isn't it? Yes. So go ahead and find that. Tell me what you get. What did you get? 5.7. So 5.7 is D. It might even be useful, and this will come in handy later, to actually draw in that midline. So just sort of eyeball where you think 5.7 would be. Sort of draw a dash, or it could be a solid horizontal line there. So that's the midline. Now let's talk about how do we find the amplitude. How can we find the amplitude? And then what? Mm-hmm. So what are you going to get for that? So remember, the amplitude is going to be the distance. I mean, that's not the only way to do it, what Sophia described. Because now that you know that this is 5.7, you can also figure now how far do you have to go from 5.7 to 11.3, which is hopefully the same answer that you have to go from 5.7 down to 0.1, right? You can also figure that your amplitude is going to be half of the range. So half of the maximum minus the minimum. So half of 11.3 minus 0.1. So 5.6 is your amplitude A. So this confused some students last class. So I want to point out that if you had a different kind of graph, it's a little confusing on this particular example because they're so close to each other, the 5.6 and 5.7. And that's because that lowest value is at 0.1. But if you had a graph that was way up here like this, and let's say that the maximum, let's see, let's put the minimum at, I don't know, 4 and the maximum at 10. What would the midline be? It would be 7. How do you figure that out?
10 plus 4 divided by 2.
Right? So the D would be half of the average of the two. So half of 4 plus 10. So that's a half of 14, so 7. So that's your midline. And then the amplitude would be what?
3.
Because you're going to do half of 10 minus 4. So half of 6, so 3. That make sense? Of course, with numbers easy like this, it'd be pretty obvious to figure out what's halfway between 10 and 4. And then once you have the 7, it's easy to figure out, well, to get from 7 to 10, it's 3. And to get from 7 down to 4, it's also 3. All right, so just to illustrate that that's why you do half of the average for the vertical and half of the range for the amplitude. All right, so those are easy enough. Let's talk about then the period. Now, before we talk about the period of this particular function, let's again look at our mother function for like a cosine curve. So if we're looking at a cosine curve, so it starts high and ends high, right? So you got a maximum and a maximum. You agree that this from here, from maximum to maximum, is the period. Yeah? Well, what if you didn't have another maximum, right? We have a maximum and we have a minimum. What's going to be the distance between a maximum and its next consecutive minimum? Yeah, that is half of your period. So looking at this graph, what is that horizontal distance between the maximum and the minimum? What's the value of it? 6. So half of the period is 6, which means the period for this graph is 12. Okay, let's write that down. So you can say period is going to be the horizontal distance between a max and a min, a consecutive max and min. Don't just jump over and pick any other old min. So in this case, we're looking at 2 times 10 minus 4, 2 times 6, so 12. So that's all fine and good for we know what the period is, but we have to figure out what's the value of B. Well, on your homework last night, I was giving you the equation, and you were telling me what the period was. So we just need to work backwards. How did you find the period when I gave you the equation? 2 pi divided by b. So if your period is 12, and we know that your period is 2 pi divided by b, we just say 12 is equal to 2 pi divided by b. And solve for b. Yeah, pi over 6. All right, so we've got D, we've got A, we've got B. Next up is C. Remember, C affects your horizontal translation or your phase shift. So this is where it actually is kind of convenient that they want us to do a cosine curve, because writing this as a sine curve is a little bit more challenging, not too much. So you know your cosine curve, remember, your cosine curve starts high and then ends high. So we can just say, well, why don't we just make our cosine curve start at this maximum? So if the cosine curve is going to start there, then our phase shift is what? 4. The phase shift in this case is going to be equal to 4. So we know then that C divided by B is equal to 4. And we found B earlier. So C divided by pi over 6 is 4. So what is C equal to? 2 pi over 3. So let's put all that together, the A, the B, the C, and the D, and write our cosine function. What do you think about that process? That's just part A. Yeah, kind of, sort of. I mean, it's not that bad when I walk you through it, right? Okay, what we're going to do now, we're going to do part B, but we're going to use our TI-84 graphing calculators to help us. So, oops. So I'm going to teach you something that I don't know if you've done lists before in your TI-84. We are going to take this data that they gave us, and we are going to type it into our calculator and we're going to make a scatter plot with our calculator. You're not going to have to repeat this process for the test, the whole doing this thing in the calculator. We are going to also graph the function that we created. We're going to graph that in our calculator. But it's just kind of cool that if you can plot the points on your calculator and graph the function, and you'll see how well your graph fits your data. So, see the stat button? Press that button. And you want to go into edit. And you should have list 1, list 2, list 3, L1, L2, L3. And if you went over to the right, you would see list 4, list 5, and list 6. So your calculator comes preloaded with 6 empty sets, or 6 empty lists, rather. If you have information in there, then I put your cursor at the tippy top where it says, the list is named, and you can press clear and then enter, and it will clear out your list for you. Now, what some students do when I tell them to clear their list is they put their cursor at the tippy top where it's named and they press delete, and then they flip out because, oh no, list 1 has now disappeared. You can always get it back if you press the stat button again, and option number 5 says set up editor, and if you choose that and then press enter until it says done, now when you go back to your stat edit, list 1 has reappeared and the data is still there. So, again, clear, enter will clear the list. Delete will just make it disappear temporarily. All right, so what we're going to do is we're going to put the time in list 1 and the depth in list 2. All right, if you've done it correctly, when you put your cursor on the bottom entry of your list, you'll see that right there at the bottom of the screen says L2 parentheses 7. That's the 7th entry. You should have the same number of entries in your list. If you forgot one, like let's say that I forgot to put the 8 and then I realize it, you can do second delete. See the INS, that means insert. So if you do second delete, it'll insert a 0 and then you can just type on top of it and call it an 8. Okay? You don't have to start everything all over because there's always the delete and the insert buttons. Okay. Next thing we're going to do is we are going to tell the calculator to plot that. So first, go into y equals and clear out any equations that you already have here in y equals because we don't want those to show up when we graph. Now we want to go into stat plots. See above y equals it says stat plot? So second y equals. You have 3 different plots that you can go at the same time. Just choose the first one, doesn't matter. Press enter to turn it on. And then you have 6 different types of stat plots that you can do. We want this first one. That's your scatter plot. And then the default is to have your X list be L1 and your Y list be from L2, which is where I put my data. Now, if I had, bless you, if I had put my data in like L5 and L6, you see on your keyboard, above the 1 button, you've got L1, and then above the 2 button is L2. So that's how you can call up different lists if you needed to. But I want what I already have as my default. And then for the mark, you can have these little squares or these little plus signs, these little dots. I just leave it as a little mark there. And then we'll go to, now if you hit graph, depending on your window, you may not see all of your points. You can, of course, adjust your window by hand, or if you go to zoom, option, I went too far. If you go to zoom 9, that's going to fit any stat plot that you have. Zoom 9. And then it gives me a nice window where I can see all of my points, my scatter plot. So it looks not too different than what I have on paper, yeah? So for fun, let's go to y equals, and let's type in this equation that we came up with, and it'll be very satisfying to see how well our equation fits our data. I'm just going to go to y equals and type that equation. We need to make sure you're in radian mode, by the way. All right, did you graph? Yeah, well, it's not perfect data, but it's pretty good. Isn't that cool? Yeah. Okay, so let's talk. We're about to use the calculator to help us answer part B. So part B says, a boat needs at least 10 feet of water to moor at the dock. During what times in the afternoon can it safely dock? Now remember, the way that this last point right here, this was at noon, and they want to know 10 feet after noon.
You could change the window.
Yes, we're going to change the window to what? How can we adjust our window?
Make the X longer.
We need to make the X max wider. So let's go out to what? 26? Sure. Well, we know the period is 12, so I changed it to 26, but 24 or 26 doesn't really matter. Now, if you press trace, your cursor will first appear on plot 1, and if you keep using your arrow key, it'll jump around to these different points. So just to kind of remind yourself about, okay, well, this is when X is 12, so that's noon. So this looks like it might be, I don't know, 2, 3, 4, 5 o'clock in the afternoon up here. Now I want to know when it's above 10, so I'm going to go back to y equals, and then y2, I'm just going to graph 10. So this horizontal line represents when the height of the water is 10 feet, and we want the range of time in the afternoon when it's above 10 feet. So we need to find the what?
Domain.
Intersection. How do you find the intersection in your calculator?
Calculate.
Yeah, second trace takes you to your calculate menu. So I'll give you some time to find that point of intersection and that point of intersection. All right, so in the calculator we have something like this, and we're looking for these intersections. So you should have gotten that this intersection is like 14.7 comma 10. And you should have gotten that intersection is 17.3 comma 10. We want to convert that to time. You know what you could do? Degrees, minutes, seconds. Even though degrees and hours are not the same thing, they're both base 60. So you can just go 14.7, your angle menu, which was the second apps, DMS. So 14,
The 242.
exactly. So this would basically, so if you do 14.7 DMS, you get 14 hours, so 14:42, or in other words, 2:42 p.m. Right? Okay, so then 17.3, convert that over to time. If you gave military time on a test, I would, of course, count that correct. Okay, so that's it for part B. I'm sure we've answered the question. The boat needs during what times in the afternoon can it safely dock? I mean, so you can say, like between 2:42 p.m. and 5:18 p.m. is when it can safely dock. All right. Part C.
Do the same thing as part A with the sun.
Well, let's think about that. Part C asks for a sine model. Is the vertical translation going to be is going to be different for a sine curve?
No.
Is the amplitude going to be different?
No.
Is the period going to be different?
No.
The only thing that's going to be different is the phase shift. So we have D, A, and B. We just need to figure out a different value of C. And since we know that, so if we go back to our scatter plot that we did by hand, and we now want this to start maybe right here. So I just need to figure out where does my midline intersect with my curve. Let's go back to our TI-84 and make Y2 5.7. That was our midline. It is 1. So yeah, if you find that point of intersection, that's 1 comma 5.7. So now we know that our phase shift is going to be 1. So C divided by B is going to be 1. B is still pi over 6. And of course now it's going to be A sine of BX minus C plus D. So there's your answer for part C.